So have you ever stopped to wonder what really runs our global financial system? I'll give you a hint. It's not some shiny new app. It's often code that was written before we even landed on the moon. Today, we're diving headfirst into this massive challenge of modernizing that critical, old code. And we're asking the really big question. Can we build an AI that's not just smart enough to rewrite it, but smart enough to check its own work so we can actually trust it? Let's get into it.
Okay, so deep beneath the surface of our modern digital world, there's this massive, basically invisible engine running on ancient code. These are the legacy systems that power pretty much everything, from your bank account to government services. And, well, that's where we run into a huge problem.
Get this, COBOL, a programming language that was created way back in 1959, is still the absolute backbone for some of the world's most critical infrastructure. Seriously, we're talking about the systems that handle trillions of dollars in bank transactions, process insurance claims, and manage government records. It's incredibly reliable, for sure, but it is also incredibly old.
So what do we even mean when we say legacy code? It's not just about the old language itself, right? It's the whole shebang. Critical applications running on ancient databases and ancient systems that are just incredibly difficult and, frankly, super risky to try and move to the cloud or any other modern platform.
And this brings us to the real ticking clock here. The generation of programmers who built these COBOL systems, the ones who know them inside and out, well, they're retiring, and there's a massive skills gap behind them. So the real question is, who's going to keep these absolutely essential systems running? This is the urgency that's driving this whole conversation.
You know, for decades, this has felt like one of those impossible problems to solve. But now, a totally new player has entered the game, generative AI. And it's offering a new hope, a potential engine to finally modernize these giants.
And we're not just talking about some simple line-by-line translation. No, think much bigger. These modern AI tools can analyze the entire legacy system to understand what it's doing. They can perform these huge systematic code transformations while making sure that crucial business logic stays intact. They can automate testing, handle security updates, and even generate documentation for code that hasn't been touched in decades. It's a full-stack approach to the problem.
But here's the catch, and it is a massive one. AI is incredibly powerful, but we all know it's not perfect. When you have a system that handles billions, maybe trillions of dollars, mostly correct just doesn't cut it. The new code has to be a perfect, one-to-one functional match of the old code. So, how can we be absolutely 100% sure?
And this quote from a recent IBM research paper just hits the nail on the head. Even with these super advanced AIs, you just can't trust the translated code right out of the box. And that leaves companies stuck with this slow, expensive, and frankly, error-prone manual validation process, which kind of defeats the whole point of using AI in the first place, right? So this really frames the central conflict perfectly. On the one hand, you have the incredible promise of AI, the dream of modernizing these massive systems without shutting down the business. But on the other hand, you have this immense risk that a single, tiny translation error could lead to a catastrophic failure. Okay, so how do we solve this? Well, this is where it gets really cool. To solve this trust problem, researchers at IBM have developed something truly innovative. It's an automated framework that's designed to guarantee the AI's translation is functionally perfect. They've basically figured out how to teach the AI to check its own homework, with almost perfect accuracy.
All right, let's break down how this actually works. The process is brilliantly logical when you think about it. First, the system generates a whole bunch of really good tests for the original COBOL code. Second, it runs that old code and captures every single output, down to the last byte. Third, it automatically creates an equivalent set of tests for the new Java code. And finally, and this is the magic part, it runs the Java code and compares the results. If every single output matches perfectly, you can prove the translation is trustworthy.
So here's a look at the whole system in action. Let's just follow the data, right? It starts on the left, where the original COBOL program is fed into a test generator. This thing creates a baseline of inputs to check every possible function. Then the COBOL runner captures the exact outputs from that baseline. All of that data gets passed over to the right side, where a new test is generated for the translated Java code. It's a totally closed-loop system designed to build that trust by comparing apples to apples, all automatically.
So you might be wondering, how does it generate such good tests? Well, the secret sauce is a pretty advanced technique called symbolic execution. Instead of just kind of guessing at inputs, it mathematically analyzes the code to explore every single possible decision branch and path. This ensures that the tests it creates are incredibly thorough.
Okay, that all sounds amazing in theory, right? But does it actually work in practice? Let's get to the results and see how this thing performed when they really put it to the test.
The results are honestly staggering. They tested this framework against a huge internal IBM dataset of over 54,000 COBOL programs, and the test generator achieved 92.8% full branch coverage. I mean, that means it successfully tested nearly every possible path in this absolutely massive and complex codebase.
And what does all that test coverage actually mean in the real world? Efficiency. This automation led to an average reduction in the time it takes to validate the code by up to 80%. That's just a massive saving in time and manual effort.
Let's make this even more concrete with a specific example. Validating this one particular program took a human expert 55 minutes to do by hand. With the automated framework, it took just 10 minutes. This is the kind of jump in productivity that makes these huge modernization projects actually seem possible.
And really, the researchers' own conclusion says it all. This isn't just some small improvement. They found that this methodology fundamentally changes the game for code translation, making it faster, more reliable, and ultimately something you can actually trust.
So the big takeaway here is so much bigger than just COBOL. The real challenge was never just getting an AI to write code. It was getting an AI to write code we could prove is correct. This framework for creating automated trust is a massive leap forward. And it leaves us with a really fascinating question. If AI can now reliably check its own work, what other giant, unsolvable legacy problems are we about to tackle next? Think about global logistics, healthcare records, even air traffic control systems. All these massive industries built on aging code. The game may have just changed for all of them.